Hello, can you hear me? Perfect. I can hear you and see you now. Can you hear
Oh,
me?
okay, okay. I can hear you too.
Yeah,
Nice.
I think it's because the connection.
Okay, okay. Cool.
Okay, cool. And by the way, my name is Yao. What's your name, please?
Swarna.
Suwana. Nice to meet
Yeah.
you.
Nice to meet you too, man.
Okay.
All right. So this is my
Let's
second
get.
Pramp session, and I just started today. Okay, just letting you know, just in case I'm doing
Right.
anything
Yeah.
wrong, just let me know. What about
Yeah.
you?
Yeah. Yeah. I've been here for I think almost 20 or 30 times for the past few months. So yeah. So yeah. If there's anything not clear, and then we can discuss.
Okay, cool. So
Yeah.
I guess I'm interviewing you first.
Yeah, I think this
Okay,
is a
okay,
question for me. I think
okay.
we have a one hour section and then 30 minutes for each person.
Yeah, okay.
Yeah, let's
Yeah.
get.
So you see the problem, right? You just have to sort by absolute value, a list.
Okay, let me take a look at it. Given an array of integer, write a function that sorts the array according to the absolute value of the number in array. If two numbers have the same absolute value, sort them according to the sign. Okay, which means that the negative will come first, right? Okay, yeah, negative come before the positive number. Okay. Um. Okay. Okay, for this example, I'm seeing two. Okay, so I have a -2, I have a -2, -7, and also 0. Okay, so okay, let me make sure I understand the answer the question first. So we are given an array looks like this, and then we take the absolute value of it. Let's take a look. So it looks like this. Calling absolute array, which is basically take the absolute value of every single one of them.
Mhm.
7, and then after that, what we're gonna do is to sort it. Right? Sorted absolute array, which is let's see what we got. So 0, 2, 2, and 2, and 7. And what we need, so what is needed is actually the one that has the original sign, right? Because after we sort it, we kind of lose the information, which is the sign, right? This is my
Mhm.
understanding, okay, right? And also, um, you know what? I think also we can construct one more step. I can call it sign, uh, which is the basically it's the absolute. No, it's the original array divided by the absolute array. Okay, I think so. I will be getting 1, -1, and
Mhm.
-1, and then -1, and oh, 0 divided by 0, which is something I gotta handle. So in this case, still NaN, right? And which I have to consider for that. Which I would deal with. I mean, I can put it as a positive one. It doesn't really matter at that point. I think it's 0 anyway. So after we add the sign array, and after so let me put it aside to make sure that I haven't gone to this part yet. This is where I need to go, and this is where I'm at, right? So this is what we can do, and the sorted absolute array, and then what we're gonna do is to have an element wise is have the sign array, and then times the sorted absolute array, and this is where this can get to where we need to go, right? Do you agree?
Yeah, that's one way you can do it. Yeah. So sorry, this is my second interview so far. So like, as the interviewer, like, what should I do? Like, I'm seeing you have a solution here that you're getting to, right? But should I be like talking to you right now about like optimizing it right away, or is that something like I let you do it first and then we talk about it after? Like, what do you think is better?
So different interview have different style. I mean, it really depends on which one you like, but the guideline would be um the interviewee, which is me in this
Yeah.
case, right? And then I walk through my understanding of the question. Did I get it
Hmm.
right? And secondly, will be do I have any constraint questions that I maybe ask you? And then I will walk through with you, like either pseudocode or like verbally walk
Okay.
through with you the general algorithm before I get into the code, right? It's why I communicate with the interviewer, which is you,
Yeah.
saying that you think this makes sense, right? And then I
Yeah.
will get a permission from you saying, oh yes, you can go ahead and code, or you can say this is not good enough. You will need to optimize before you get into coding, right? And also
Okay.
also a question that you might want to ask would be time complexity and space complexity, right? So if you
Yeah.
have a brute force approach which is really lousy, which is really bad, and then you might not want me to waste your time to code it up, right?
Okay. Okay.
So so yeah. Again, the general guideline will be optimize first before code it up. That's all.
Okay.
That's how I would. That's how I
That's how you would
usually
prefer
do
as
it.
well.
This is how a normal guideline for
Okay.
most people. But you have different style that you prefer,
Okay.
right? Everybody
So
is different.
okay. So right now, how much space are you using for this?
Yeah. So for it's kind of wasting, right? It's pretty wasteful for for the space, right? So I'm seeing the original array, absolute array is another one is a big O(n), and I have the sign which is a big O(n) as well, and also I have the sorted is another big O(n), and I
Yeah.
have another one. So it's big of almost 3 or 4 n. But
So okay.
I dropped a
So
constant a little
let
bit.
me just ask you, how do you plan to sort? Like, what are you gonna do for sorting? Like, forget about the absolute value for a second. What would be your technique for sorting right now?
I would just use the building function or Python to sort it, the team sort.
Oh, you're just gonna
That's how.
use that. Okay. Yeah. So, in an interview setting, do you think they'll let you use the because the whole question here is about sorting. Will they just let you use the built-in sorting, or
Yeah, it depends on the question. Sometimes it doesn't. Sometimes it doesn't. Yeah,
yeah,
if the main point is about sorting, obviously you cannot use this something to
yeah,
cheat, right?
yeah? So it's
So
not really about cheating or not. I'm just saying because it's like that's kind of the point of the question, right? So I'm okay. I'm gonna because if you use the Python built-in for this question, you can just solve it in one line, actually.
okay,
Yeah.
okay,
So So I'm gonna ask you something else. Do we need to
right.
even create these signed arrays and absolute arrays, and then do this operation between those two? Like, do we even need to do that?
Mm, yeah, I that's a good question. So it
Because
feels like I don't. Go ahead.
like when you sort, you're using any of the sorting algorithms, right? Whichever ones you can think of. There's several, right? Like, but like whichever one you use, I feel like you don't have to do this. You can just do the comparison within the algorithm. So like you would just, when it comes time to compare any two numbers, which is like in every sorting algorithm, you're always going to compare, right? Two numbers in an array at some point, right?
Yeah.
Yeah, whichever one you use, whether it's quick sort, merge sort, binary insertion sort, like whichever one you use, right? At some point, you're going to do a comparison between two numbers, right?
Yeah.
Yeah. So when you do that comparison, can't you just do the comparison there, like of what you're trying to, like, because here we're talking about absolute values, right? So like, that's why I'm asking you, is do we even need to create like all these entirely new arrays and stuff?
Okay, you mentioned about comparison. Also, you kept mentioned about I may not need the absolute array. Also, I don't may not need the sign array. Okay, let me think.
So okay,
Also, I cannot.
I might have distracted you a bit. Okay, so the thing is, you're sorting, right? Let's say I'm not letting you use the built-in, right? Let's say I'm being a jerk and just not letting you use the built-in, right? How do you plan to sort? And let's say it's not even absolute values, just integers. What technique would you use?
Yeah, so there would be a couple of sorting algorithm, which would be um, some of the possibility would be using merge sort or a quick sort or bubble sort,
Yeah,
right?
yeah.
So
So
this
which one do you want to use? Which one do you want to use right now? If you had to do it right now.
mm, maybe we can use quick sort, and
Okay.
which is the yeah big O n log n time complexity. I think this is one of
Yeah, and what do you
the
do in a quick sort? What is the basic idea?
so what we do is to find a pivot
Mm-hmm.
and then compare and then look through the elements. If that number is, if I remember correctly, if that number is smaller than the pivot, and we will leave it, and if it's bigger, we will do a swap, and then we will increase. So we have the two index going on,
Yeah.
and then when that number is greater, and then we will yeah. I don't remember exactly, to
Okay,
be
so
honest.
I'll just give you a hint. The basic idea is, yeah, you pick a pivot and you go through the whole array. I'm just giving you the general idea. We don't have to talk about indexes yet or anything, but every number that's less than, you put on the left side, right? Every number that is greater
Yeah,
than, you put on the right side, and then the pivot goes into the middle. It's not always going to be
yeah,
even, but on average, it's going to be half half, right? And then
yeah.
what do you do? What do you do after that?
And then after that, we just do do it on the left and also do it on the right,
Yeah, yeah, yeah. You
and
do
then
the recursive call
yeah,
on the left and the right. Yeah, yeah. You're
yeah,
absolutely right
exactly.
there. So that's why I'm asking you, because now think about the absolute values, right? Do we do you think, given that what you just told me, right? Do we even need to make a new array, or like use these absolute arrays or signed arrays or anything like that? Do we even need to do that?
Okay. Let me think. So maybe I can separate between the positive and negative. And then so take the zero as a pivot. Everything on the left will be the negative. Everything on the
Okay.
right will be positive. But
Okay. Sorry, I think I confused. Okay, I think I'm putting you on the wrong track here. So when we pick the
right.
pivot, we can still choose any number, right? So when we do a compare, the whole point I was trying to show you, right, is that whichever sorting algorithm you use, you're always going to compare two numbers at some point, right? So in quick
Yeah.
sort, a pivot, when you use the pivot and you go through every other number to determine if you put it on the left or the right of the pivot, you're comparing the pivot plus one other number, right? So we can just check the absolute value of each, right? At that step.
We can just check the. Okay, I know what you're saying. So
Yeah,
when we are comparing, you just directly check the absolute value when we do the
yeah,
comparison.
yeah, yeah. That's essentially it.
Oh, okay. But but if we do that, we might lose the information of the sign of the original number then.
No, you don't have to. We can just do the comparison. We don't have to modify the number. We can move it whichever way we want. But when we're checking for comparisons, we just use the absolute value, right? How do you check the absolute value? It's just a function, right, in Python?
Sorry,
It's
say
like
that
this.
again.
It's
I
like
didn't
this.
get it.
It's like this. You have x and y, right? You just do a check between these two, and then you just move x
Yeah,
or y wherever you want to move them.
yeah. I understand that. But when we return it at the end, um, we have to return the original number, right, which has the sign.
Yeah. So when you're rearranging, let's say you have x and y, and let's say absolute value of y is greater than x. When you're doing the rearrangement, when you're doing the comparison, you don't have to do this. You don't have to have it like this while you're working with it. You can just do the
Oh,
comparison and just put it like this, right? You're
right,
not
right.
losing
Yeah, I
any
get it now.
information. Yeah.
Yeah, I get it
Oh,
now.
yeah. In this case, yeah. Oops. That's what I mean. Yeah, yeah, yeah. That's what I meant.
Okay, yeah, I think um yeah, I get it what you mean. But
Okay, given all that, you can do it however you want. I understand like interview setting. There's extra pressure, and you know, because I'm just telling you no, like because when I watch someone else do their stuff, and like I just want to give like I just want you to do the optimal. I just wanted you to do the optimal way. Because if it was me, I want the person to tell me that there's a faster way to do it right away, like or more optimal right away, right? So I'm just letting you know, but you can do it however you want.
yeah, I think this is definitely gonna work. I think so. I'm not sure if this is the most optimized solution, but I think the time complexity will be the same as a regular
Yeah,
sorting,
yeah. Time
right?
and
So
space complexity will be the same for sure. Yeah, yeah.
yeah,
But
so
I'm just thinking in terms of because like in a Google interview, they might ask you the same stuff. Like, do we need all this space to do this? Like, because you're going out of your way to create entire arrays, right? Even though it's the space complexity, time complexity is the same, it's a little redundant, right? It's like extra unnecessary work, right? Like we don't need to
yeah,
do it.
definitely,
Yeah.
that definitely will ups the optimization before the coding. This is exactly what we did, right? What we are doing right now. So you ask
Okay.
me, is it necessary? Do we need those? And the answer is no. And this is how the iteration of the conversation goes. And then when I get a green line from you, and then I can start coding. This is how
Okay. Okay.
typically works.
Okay. All right. So what's next? Do you want to talk about how you're going to implement this, or are you going to do the
Yeah,
quick sort, or what are you doing? Yeah.
we can do the quick sort right now. I given that I have the 10 minutes left, I
Yeah.
actually
Sorry about that.
don't.
Yeah.
No. Don't sorry, and don't be sorry. And actually, we're making a lot of good progress. But I honestly I don't think I can code it up in 10 minutes because
Okay.
uh yeah because I don't remember the algorithm honestly.
Okay. Yeah. You just need to
Yeah, but I
practice
can.
more. Is what you just need to practice. Is what you're saying.
Yeah, sorting is really my weak
Yeah,
spot
yeah.
actually.
So since okay, I'll just I guess you're okay. So I'll just tell you just my insight if you want on this type of thing.
Sure.
Yeah.
Yeah, you
So
can. Yeah.
I would just recommend you. Yeah, because this is the if you're trying if you're going to probably go and practice sorting, right? That's what you're probably doing,
Yeah.
right? So I would
Yeah.
recommend
Exactly.
to if you're thinking about how to spend your time efficiently, I'd recommend you look at quick sort and merge sort. Why? Because those two techniques I've seen being used in bigger problems. Like you make an alteration to solve the problems. So I'll just give you like quick examples of two problems. I'm not going to solve them, but I'm just going to tell you. So like
Right.
say you're given a bunch of numbers, right? Like ARR just now, Find the kth largest number. Have you ever seen this type of problem before, or?
Yeah,
Okay,
yeah, I've seen it, and the way that I approached this was use a heap.
a heap. Yeah, yeah, yeah.
Yeah, and
Oh, true. So then it's just what? So you scan through the array, you insert elements into the heap, and you keep the tops. You keep the top k elements, is what you're saying.
yeah, yeah, and then we just keep popping off until we hit the kth
Yeah, 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 yeah.
element.
So actually, if you know, this is the thing, right? You can actually do a faster way if you know quicksort.
Okay,
Okay, so
that's
if you
right.
know how to do quicksort, right? This is why I say quicksort and merge sort for other problems. But quicksort is, as you said, right? You pick a pivot at some point, and then you find every element less than it and more than it, and then you split up the array, right? Left side is the less, right side is the greater, and you split on the pivot, right? But
Right.
for the kth largest element, you can do quick sort, but you don't have to sort both sides after. You only have to travel down one side. So let's say you pick a pivot, right? You're trying to find the kth largest element. You're trying to find the pivot. You choose a pivot. Let's say it's less than your element. Then you know that that the kth largest element. Let's say, okay, sorry, I confused it. You find the pivot, right? And then you see how many numbers are less than it and how many numbers are greater than it, right? Because
Right.
it's not always going to be the same. Sometimes you get lots on your left side or less on your left side, and on average it will be half-half, but you don't know, right? So let's say you have more than k numbers on the right side. What does that say about the kth largest number? Let's say you pick a pivot and you have more than k numbers that's bigger than it.
Oh, that means the number we picked was too small.
Yeah, it's too small, but more importantly, which side do you have to check now? Which side do you recurse
Uh,
on?
yeah, on the other side, on the right side.
Yeah, on the right side, right? And we don't even have to sort the left side anymore because we're not doing a quick sort. We're only finding the kth largest element, right?
Oh, okay. So you basically iterating or the left hand side or the right hand side to see how many numbers is bigger or less than.
Yeah, you're doing a quick
Okay,
sort, but you're not sorting half. Normally you sort both halves, but in this case, we only sort the one half. In quicksort, we choose a pivot and then we sort left and right, right? But in
yeah,
this
yeah,
case, we only
yeah,
sort one side, right? Because
yeah. Just
whichever
so
side the kth largest element is in.
yeah, just okay. I get it. So basically, we're sorting the side that we need.
Yeah, only the side that you need, and then eventually, based on how many elements you have on the right or left, you will eventually find the kth element if you choose your conditions correctly. Because if you have more
Oh,
than
okay.
k on the right, then you go check the right. If it's less, then you check the left, right? And you keep doing that. And on average, what's the average runtime? If you on average, you'll cut out half the array each time, right?
Oh, because it's lock in.
Yeah, yeah, yeah. So the first level will be you check n numbers, right, for the quick sort, right? Second level, you'll check half the numbers, right? So n over 2.
Right.
Third level is n over 4, right? And all the way to 1, right?
What legal problem was it? This one is interesting.
Oh, it's find the kth largest number. Just Google leak
Okay.
code,
Yeah.
find kth largest number, yeah. And look, if you have the
Okay.
access to the solutions, like if you subscribe or something, you can definitely find it on there. Yeah.
Yeah. I will look. I will look that up.
Yeah, because it's because the runtime of that is n on the first level, n over 2 on average on the second level, n over 4 on the third level, so on. If you add that up, n plus n over 2 plus n over 4 all the way to 1, it's just a mathematical series. It's you can think if you're just trying to simplify it, it never exceeds 2 times n. Because you go n plus half of n plus quarter of n, you never reach 2n, right?
Okay. Yeah. Yeah. Yeah.
If you think of it like
It's
a
a sum of this.
pizza, yeah, if you think of it like a 2 pizzas, right? You have one pizza, then half a pizza, then quarter of a pizza. You never get two pizzas, right?
Yeah, it's a sum of sequence. Okay,
Yeah.
that makes sense.
So that's why the runtime is on.
Cool. Wow.
Yeah.
Yeah, that's
But you
good
would
to
only
see.
know that if you practiced quicksort, right? So that's why
Yeah.
quicksort is one of the ones I would recommend you put your time into practicing, and merge sort. Merge sort also comes up. I've seen in other problems.
Yeah. So the sorting algorithm is really my sore spot. Sore spot.
Yeah.
Yeah. I will go back and
Yeah,
improve
for
myself
sure.
in that
I also had problems with
area.
sorting too. You just have to practice because it does. Sometimes you think, oh, I don't need to sort because we have the Python sorting code and sorting a function and
Exactly.
everything. Yeah, but sometimes the insight does matter. Like in that case, it gives you a better optimal time for that
Yeah, I
problem.
think most of the sorting slash searching that I'm seeing is binary search. I think that's very common. Occasionally
Yeah,
we can see, yeah. So that's why I haven't practiced myself enough for sorting algorithm,
yeah.
which I'm gonna do. Um, okay, now I bombed my section, so we can switch to your part.
All right. Okay.
Okay, let's swap.
Flatten a dictionary.
And by the way, just some feedback. I think you are being really helpful and constructive interviewer. Um, so I mean, now you are on the other side of the table, so you know more about. I mean, well, being a good interviewee actually, right? Because you are on
Yeah.
the other side of the table, that helps from that perspective. And this actually did help me, and at least. So I think I hopefully you get the same feeling and the same thought.
Okay.
Anyway,
Thank
yeah. Now it's
you.
your turn, and I'm gonna interview you right now.
Okay. So I'm just reading.
Yep.
I see. So basically, we're taking a dictionary structure, we're flattening it, and the key value will be like kind of like not like analogous to like a directory. The name will be like okay, okay. I think I understand the problem. So okay, I will
Right.
do what you did. I'll do this.
Yeah. Yeah.
Yeah. So we get something like that. I mean, yeah,
Right.
we just turned it into we just want to turn it into this. So
Right.
we can see here, key one is already flat, so we just leave it as is. Key two is there's a dictionary nested in there, so we check every key, and then whenever we have like a terminal value, as in not another dictionary, we we just have that entry there. And every time we recurse into a dictionary, our key is adding a. Sorry, I have music playing all of a sudden. Pause it. Our key is adding. We're just adding the name of the key to the. Okay, so I get the problem, but my explanation skills are not very good at like showing you I understand the problem. Can I just start coding like so? Okay, I'll tell you what I'm doing. I've not
Yeah. I
displayed
mean,
that I understood the problem, but can I explain just what I'm doing? I guess.
well, I think you get it quite well. Basically, the key being the all the concatenation of all the parents and also
Yeah, yeah,
the
yeah,
child, right? The children, and then and when we get the bottom of it, the value will be the value from the most inner child, right? So I think you get that. It's pretty
yeah.
straightforward. But before getting the coding, um, I would like to slow you down a little bit and tell me how would you approach it and what kind of method that you are applying here. Also, the space and time complexity you are thinking of before coding.
Okay, so I think since the dictionary is a recursive nested structure, we can just use recursion, right?
Right, right.
Yeah. And so in our recursion, we're gonna, we'll start with the root dictionary, and then we'll just be like, for each key in the dictionary, if it's not
Okay,
a dictionary, then to our result, we'll just add the key and the value, right? But also,
okay.
since we could be in a nested dictionary as well, I guess in our recursion call, function call, we'll have the string of the concatenated keys up till now, up to down to this level. And
Okay.
then so that's what we'll add our current key to that, and then that's what the result will add. So we'll just add the concatenated key plus the value if it's not a dictionary that we're looking at.
So this is a you use the word recursion, which I
Yeah.
like. Um, do you think this is a BFS or DFS problem?
Oh. Uh.
I want you to think of in terms of graph.
Oh. So is there an okay? So I actually didn't. Is there an ordering that? Oh well, actually, it's a dictionary, so ordering doesn't matter, right? For
Right.
the keys, right? Because it could be in any order. It doesn't like there's no definition for that because it's a set. It's a hash set. So therefore, the ordering in which we visit keys doesn't matter. I mean, if you're thinking about it in terms of BFS or DFS, as in, do you go down as many levels as you can, or I think DFS definitely works. Does BFS
Right.
also work? Um, you can do BFS, but you don't need to do it because with BFS, you I think it's overcomplicating it. Like you have to create a queue structure, and
Right.
you can still do it, but I think just for the purposes of this problem and just doing the recursion, like they're going to be equal in terms of space and time complexity, but um, with the
I mean, it's up to
DFS,
you. I mean,
yeah,
yeah, I'm just proposing that this might be able to solve by a graph, but you don't have to, right? If you are comfortable with recursion, you feel free to go ahead with that
yeah.
as well.
It is
That
in a sense a graph. Even if you do the recursion, a
yeah,
graph can be abstract. You don't have to necessarily write it in code, right? But like, it is a graph pretty
exactly.
much because you go down to key one, it's connected. In this case, if you go down to key two, it's connected to key A and B, right?
Yeah,
But
there you go. Yeah, this
yeah,
is something that I wanted you to think
yeah,
about. Yep, yep,
yeah. That's like conceptually, it's like that, but we don't have to write it like that, like because it is a graph structure. But you can think of it in if you think about the recursive technique, you do use DFS, even if it's not
okay.
it is a graph technically, but we don't define any graph structures. It's just we're just using the keys of the dictionary, right?
Yeah, I like your answer. So one last question before we get into coding. Um, is the time and space complexity? How will you
Okay,
analyze that?
so I would analyze it based on, so you give me a dictionary, and for each value in the dictionary, we will add to our return value. Yeah. So in this case, we have in this example, right, key one, that's one value here. In key two,
Right.
yeah, you have a dictionary, but how many values are in that dictionary? You have two
Okay.
plus another nested dictionary, right? So three, and then here you have another nested four. So actually, let's see. So there's values, but then there's also keys. Um, I mean, we can say if we define the size of the dictionary you give me as the keys plus the number of values, the number of keys plus the number of values, the work we do is also that. linear with
Yeah.
respect to
So
the key plus values.
yeah. So for this particular example, we have how many keys? One. So we have key one, key two, A, B, C, D, E, and MT. Right. So 1, 2, 3, 4, 5, 6, 7, 8. We have 8 keys. And how many values we have? 1, 2, 3, 4, 5. We have 5 values.
Yeah.
And then, I mean, other values would be another
Yeah.
dictionary, as you
Yeah.
mentioned, but the core value we have is
Yeah.
5.
For each of those
So
13, we either add a value to our return result or we recurse again. Those are the only two things we do.
right. So in terms of the time complexity, would you say is a number of the big O for number of what?
Big O of n. If let's say big O of k plus v. If the dictionary has k keys and v values.
Yeah, because we might have another dictionary for the values. Okay, that makes sense.
Yeah.
Okay, so it's a linear time. That's your takeaway, right?
Yeah. Yeah.
Okay, good. I think we are good to code.
Yeah.
You answer all the question, all the barriers. So yeah, let's code it up and
Yeah.
let's see how it works.
Okay. And space complexity is going to be also k plus v, by the way. And in the worst case, we could have a bunch of nested keys and one value at the end. So the stack call, the recursion, will go down all k values.
Yeah, right. You get the bottom of it, and then each of the recursion just keep it on the call stack.
Yeah.
Yeah.
Okay.
Let's go do it.
So let me define a helper function, right? So
okay.
We go, we can do we'll just call it DFS even. Yeah. So what we have in this input, we need the accumulated key so far, right? The default would be just an empty string, right, for the root. But yeah, we need to keep track of this. And then also the dictionary we're on. So it would be, oh, this is reserved. So I'll just say D for now. So if oh wait, there's multiple ways we could do this. So we could say val. So if
sorry, I'm gonna quickly go to the kitchen and turn off my oven, but I'll come back with
you. Okay, true.
Okay. Yeah. Give me 1 sec. Okay, sorry about that. I'm back online.
It's all good. Do this. Ret. No, not ret.append. Ret accumulated key is equal to val. So this is the base case. If we have an accumulated key and the value associated with it is it's not a dictionary, then to our result, which will be like at some point here, it'll be like, this is our return array that will return at the end. But we'll just add the accumulated key onto it. Otherwise, we have to do some recursion here. So for key in val, it's a little confusing. So I'll just say D, 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 because this could be a value or a dictionary. So for each key in this dictionary, we just do the same thing again. So DFS, but this time it'll be, okay, so accumulated key plus key. That's going to be our our key for the recursion step. And then this will be D key. Yeah, we can do for key val and items. Just do it like that. Yeah. Wait, actually, is that it? Am I done? Wait, let me check. The base call will be so let me check the inputs. The input is always going to be a dictionary. So our base call, definitely we can run like this. It will if the dictionary we're given is, oh wait, we have to do this before that. Dictionary. If it's not, if we're just given this, if we're just given this, then for key 1, 1 will recurse, and then we'll come up here, it'll be key 1 and 1, and then that will be added because 1 is not a dictionary. So that will be added, and then we'll return. And then for this stuff, for key, yeah, it will return, and then we'll go here. Key 2 will be a cum key, and D is not a dictionary. No, it is a dictionary. Key 2 is a dictionary. Yes, it's a dictionary, so we have to recurse on each of these members. So then it'll be key 2 plus A for the first call. Oh, I forgot the dot, right?
Yeah, exactly. Yeah. I think I think you get it already.
Okay, yeah. Sorry, yeah.
Yeah, don't overcomplicate this. This is not that hard.
Yeah.
But I think you got most of it. But the one last thing that I didn't get it the first time was for the last pair. It is over here, right? So, which I didn't get it as well. So in here, this is the last one, right? And look at and the interviewer actually asked me that question. So we look at this dictionary, right? So the last key. So you scroll up, right? The example. When the key is empty, do we have to do we have to still concatenate the dot?
When the key is empty. I skipped over this part. Shoot. Okay, I didn't read this part. Okay, let me think about this.
Then that's the only thing that you might have to think of. But that's about it. That is.
Oh. So I mean, wait. If it's empty, then just exclude it. Okay. If
Yeah, exactly. Yeah, as simple as that. Don't overcomplicate this. It's not.
Yeah. What about? Let me think about if we're given a base.
You don't. Yeah, you don't want to. You don't want to skip that. You still want to do it, but just some modification on the key, right? You still want to pass it to the next.
Oh, I see. In the output, he still has the 1. Okay.
Yeah. There you go. Yeah. Okay, I was confusing you.
Oh, okay. No, no worries, no worries. No, I didn't read the problem. That's my fault. So
Yeah,
okay,
no worries.
let's
I
let's
didn't.
let's
It
do
didn't come to me.
something. Yeah, so it's just different here.
There you go.
So
Perfect.
here,
Yeah, I think as simple as that. Yeah.
yeah.
Um. Yeah, I think that's basically it. That's the solution.
Okay, let's run it real quick. Is this indentation error? Maybe.
Something is not defined. Maybe I don't know. But I think this is how I
Yeah,
would solve
yeah.
this.
The last problem I did, there was an indentation error. Like it thought it was a function or
Yeah,
something.
yeah. It's more error here and there, but
So
uh,
there's some. Okay, let's try this. Okay, the code runs there.
still not defined.
Let's see if it comes here. Oh, it comes here. Um, what? Oh, maybe this. Wait, what? Do you know why there's a red outline here?
Yeah, that's a mystery that nobody knows.
Okay, let's try it. Oh, I'm returning tests now. Oops. Yeah, I had this
mm,
same issue in my previous problem as well, but in that problem is the indentation of the last couple lines. Like it's not reaching.
this.
Yeah, like it's not reaching somewhere. This IDE is really tricky with the spacing. Oh. Ooh. Oh, did I even use this function properly? Let me check Python is instance.
I think you could. The function I used was the type.
Oh, type of
Yeah,
or
the
just
type of
type.
something like that. I don't remember exactly. It's type dot for I think it's for JavaScript maybe. And then you check the type. Is that the same as a dictionary or not? Um, that's the one I used. Let me check my solution. Give me one sec.
Oh no,
But I think
here we go. I didn't return. That's a bug. I didn't
okay.
return here. I have to return, right? Because it's trying to do the keys. Let's say this is just 5. I just continued on, right? Let's say this is
Okay.
not a dictionary. I still went here. Let's say this wasn't a dictionary. My code was still going here because I didn't have the return. Okay, I don't know. Oh, red. What is going on here?
Yeah, you're getting something. From the bottom.
Oh, the
Let's
root is
see.
supposed to have a dot? Wait, oh no, my actual has a dot. Whoops. Oh, I see. Yeah, I'm adding the dot right away with an empty string here. I see. Yeah. So, uh, one, two. Let me see how many keys here. 1, 2, 3, 4, 5. 1, 2, 3. So yeah, I'm correct, except I have a dot at the beginning because I'm doing this. Yeah. So I can just.
Yeah, so
Uh,
little things like that on the keys thing. Yeah, as I mentioned.
yeah, so I could just do a out parent call if I'm just trying to bandage this right quick, so I can do. Uh, or I could just do. Yeah, I would rewrite this function differently, but just to bandage this right now, I'll just do this.
Here is the same as the one above. Oh, okay. There you
Oh
go.
wait, if
Okay.
accumulated, yeah, sorry.
Okay. Yeah, I think. Yes.
It's running.
Perfect. Yeah,
Okay,
you pass all of them. There you go. Perfect.
nice,
Good job.
cool.
Yeah, I think in a real interview, where we are typically we are not giving an IDE. You first, I mean,
Mm-hmm.
even there's a little
Yeah,
bug like that. I mean, in a dry run, you probably would have catch those. Um, because typically we run the code manually, right? So even though those code like those bug like a typo, they are not being catched. Probably the interviewer will pass you. I will pass you.
yeah, 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 yeah. Yeah, it's just good. It's
But when
just good
you
to be. It's just good to like just to practice and avoid those. I think just having it clean is nice. But yeah, for sure. If I had the choice to, I'd write it clean for sure. But yeah, just those things like that, it always gets me. Yeah.
Okay, yeah, I think you have done a good job. I always spare 5 minutes at the end to speak with my prom friends. I'm not sure if you have the 5 minutes to talk. Just
I
talk
have
about
time.
experience. Yeah, yeah. Uh, I want to share with you a little bit. I mean, I go first. I can share with you a little bit of where
Okay.
am I on the stage of interviewing.
Okay.
And then you can share, and then you can share your experience.
Okay.
I actually interviewed with Google almost a month ago, but I
Yeah.
didn't make it to the second round on the phone interview. They asked me to code up a object iterator, which I didn't know how to code at that time. So I was stressed out and I bombed it, unfortunately. And now I came back to Prom and lead code to practice with my guys. Um, Also, I was I was in the process with Amazon, and I we scheduled the interview a month out, but before my interview date, actually they hired somebody already, so I didn't have
Oh,
the chance to get to the final round. Which is I'm not sure that's a good news or the bad news, because the on the positive side is that I wasn't really that prepared, as you saw me on my last question. So this is a lesson I have to learn for myself. Yeah, so I actually located in Canada, working for
yeah.
as a programmer for a bank. Um, yeah, so that's my story actually.
Okay. I'm in Canada as well.
Oh
Um,
really?
yeah, I'm in Toronto. How long have you been practicing, or like how much have you been practicing? So, let's say.
I started back in 3 months ago.
I see. I
Yeah,
see.
so my progress right now is are you a student, or are you experienced
No,
programmer?
I finished school like 2 3 years ago, and
Right.
I was working, but now I'm not working because my workplace couldn't pay me. So then I started applying to jobs.
Holy shit!
Yeah,
Really?
because of COVID and everything. Yeah, yeah, yeah.
What? Can you say the what was the name of the company?
Yeah, it's
What's
just a
so
smaller company. It's called Southpaw. Yeah, just a
okay?
smaller tech
Okay.
company. Yeah, yeah,
Oh, I'm sorry to hear that.
yeah, yeah. It's fine. Yeah, it's fine. It's okay. So I started applying to places, and I started getting actual some responses back, but not that many still, to be honest.
But do you
I
guys
right.
like the? But do you guys have like a union, or do you guys take like a legal action? They cannot just not paying you guys back.
It's a really small company. Like it's really really small. It's just not like they did pay me back. They paid me back everything they owed me eventually. Like this year they did.
So the entire company being liquidated.
It's not liquidated. They've been around for a long time, right? And they kind of they just kind of reduced their budget for now. They're still going. I can go back and work and make money again, But right now, I'm just looking for other places, basically.
Yeah, that's what I would do. I mean, based on what I'm seeing from, I mean, at least the question I'm seeing from you, I think you are really prepared
Yeah,
for some of
yeah.
the interviews.
So I actually had a Google interview recently,
Oh,
like
really?
20, yeah, like three to 4 weeks ago.
How did
Um,
it go?
so they asked me to do a directory, like so. The guys he gave me like it's an open ended question, and it was
Right.
multi part, and he basically gave me a he's basically asking me to design a file system. Like he would give me a list of entities, right? Or not even a list. He was being very vague about it, right? I think he was just trying to give me as much leeway as possible to do whatever I wanted to do, right? But
Yep.
that kind of it worked against me because I was thinking in terms of leak code. I get an exact list or something, and I have to give an exact answer or something, right? But he was giving me like more vague terms, right? So he just told me an entity, a list of entities, and each of them they'll have a name, right, or an ID associated with them, and there's going to be children that points to other entities. And then he wanted me to just implement a some kind of structure, directory structure that like given an entity ID, I return the file size. So like every entity in the list can be a file or a directory, and if it's a directory, it has children, right? Like pointing to other directories or other files. And if it's a
Yeah,
file,
yeah.
it
I'm
will have a
thinking.
size, right? So then basically it's like a recursive problem that I had to
Yeah,
solve.
yeah.
I slowed down a lot first because also it was my first interview ever, like first technical interview. Um, so I was also nervous, but also since he was being very vague about it, I lost some time there. Also, he asked me to define the properties of the system, basically, like what has to be true. So like right off
That
the
was
bat,
like,
I gave for example like, oh, every entity, if it exists, it has to have an entity pointing to it, except for the root. And if an entity has children, those entities have to be pointed to. So like and then he summarized it like forest for trees or something like that. I think it's a common like property or something somewhere. Um, and then he was looking for a third one, and I couldn't give it to him. But then when I was coding it, I realized what it was. That he asked me a question, and then I'm like, oh, is that the thing that you meant? That directories cannot loop back into themselves. They can't loop back into themselves, right?
sorry, I didn't quite get it. The last one. What was he looking for? The last one that
The
you
last one
couldn't
he was
write.
looking for, you can't have cycles in the directories. So you can't have, let's say you have directory A points to B, but you
Right.
can't have B pointing to A again.
Oh, okay. Yeah,
Yeah,
like a folder, right? So
yeah,
one
yeah,
folder
yeah,
can be a
yeah,
child, and
yeah,
then for
yeah.
another one can be
Exactly.
another. Okay.
Yeah, it's a directory system, right? But I didn't think about that initially, right? But as I was coding it, and he asked me the question because I was doing the recursion, he's like, "Wait, but this can go forever," and I'm like, no, because there can't be loops back into each other. And he's like, and I'm like, oh, is that one of the properties you were looking for? And then he's like, yeah, 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 that's the one. No cycles. So then I got all the properties like that while I was coding it, and then I coded it, and then I mentioned the optimization for the file sizes. So like, if you're given like a file ID or a folder ID, right? If you want to determine the file size, you have to recursively look at all of its children, right?
Yeah, yeah,
But
exactly.
you can
Yep.
optimize that by saving it, right? You can the first time you calculate it, you can just save it into the memo, right? Of the
Oh, like a dynamic programming kind of thing.
yeah. Just basically you cache the size that you calculated on a previous operation because the he was just only asking for file sizes. He didn't ask for updates or anything yet. Like me, if I'm adding a
Yep.
file to the system or whatever, he didn't ask for that.
Do you have to sort it the file size that you? I mean, like even you get to the bottom of the directory that has contains only file, like let's say PDF or text files. And then let's say a folder that you get to and has like a three files. One is a 1 megabyte, the other one is 2 megabyte, another one is a 3 meg. You have to sort it.
No, you don't. You have to add everything. because you're trying to determine the size of the folder, right? You have to add all of its children. So
Right.
you do have
Oh,
to
okay.
visit the whole
Okay.
tree. You have to visit the whole tree.
Okay, and then grab everyone and then just add it.
Yeah. I just used a Python dictionary for the tree structure. I just
Yeah,
use
yeah.
nested dictionaries. Yeah.
Yeah. This question actually is on Nico, but this is not a conventional problem. It's not like something that you can type on the IDE. This is
Mm-hmm.
actually a very, very popular question from Amazon. It's
Ah.
called it's called file system. Give me 1 sec. I'm gonna search it
Yeah.
for you.
Sure.
Give me 1 sec. This is on the discussion forum. A lot of people discuss this question that they come across. Give me 1 sec. Give me 1 sec. I'll paste a link and then you can
Yeah.
search it. Yeah, this
I,
is
I didn't code it, but I also told them how to change what I would have to change to handle updates. Like if I add files or delete files or directories, or add or change the size of a file or something. So yeah, I mentioned all that, and I got a second interview, which is in 2 days.
really? So
Yeah, phone interview in 2 days.
perfect. Oh, this is the phone interview.
Yeah.
Wow, this is a lot harder than my phone interview. Actually, let me share the link with you. Probably I wouldn't, because you will ask this question already, but I probably won't spend a lot of time on it again. But just for your reference, this is where some of the hidden question that was asked. This is not a regular typable
Yeah.
question that you can go on. This is basically people chatting on the discussion forum,
Yeah.
right? It's called Unix or Linux file search. This is a file search. It's not a file size,
Yeah.
but
Okay. So you're looking for a file.
yeah. But this is. Let me give you another link. 1 sec. I found this is all in my file actually. I organized those questions when I come across it. Oh, this one is more like a Glassdoor experience. So one of the guys from who interviewed Amazon, he shared experience that he had such an object-oriented design question.
Mm.
Some of them are more tricky than a regular, let's say, tree problems or graph problems, because you can like go any directions. Sometimes the freedom can be confusing. I mean, it's for me,
Mm-hmm.
like you can define any properties you want, any method you want, right? So a lot of freedoms sometimes can be a chaotic. I mean, at least to me.
Mm-hmm.
Okay, I think. Oh, this one I haven't given to you yet. So this one is for from Glassdoor.
I see.
So the position that you were interviewing, is that in Ontario?
So I'll be honest, I'm not sure. So I spammed a bunch of applications, and when my recruiter reached
Right.
out, like you can't see which application, like I couldn't see. Like I went to my Google job account, I couldn't see which application it was for. But I think it's probably Waterloo, or
Oh, okay.
or
Yeah.
maybe like Seattle or something.
Montreal.
Yeah.
Oh, in US.
Yeah, but I think I only applied to Waterloo positions, I think, if I
Yeah,
remember
that's what I
correctly.
did.
Yeah.
I think the recruiting process was they the team assignment. The team assignment comes after you finish all the interview rounds. So like,
Yeah.
yeah, what I heard from my recruiter
Wait,
when I
team
was
assignment? Oh, yeah.
yeah,
Oh, you mean like after you get hired, or like after they realize they want you?
exactly, yeah. And then yeah, so it's not conventional compared to other companies. This is um basically you pass all the barriers, and then at the end
Yeah.
you get I mean, I'm not sure who gets to choose the team. Is it the interviewer or the managers? I don't remember. But you gotta choose though, I mean, at the
Yeah.
end.
Oh, you get to choose?
And I don't call me on it. I don't remember
Okay.
exactly. That's what I heard from YouTube and also from my recruiter. I didn't get to that stage, so I couldn't say much about those. But the team assignment is comes at the end. That's what I
Mhm.
heard. And so now I know that you're going for the next Google interview.
Yeah.
I just want to give you a little bit boost. So the question that bombed me so badly, which was my second interview question, second phone interview. That guy comes
Oh,
from I passed the first one, which was easier than yours. Actually, it's easier. I don't remember exactly what it was. I used a hash and also use a set, and that can get me through the solution. And there
yeah.
is no IDE, so it's purely talking. So what the first phone interview was easy. The second one really bombed me really badly,
Damn.
which was the iterator object. So at that point, I don't remember what it was iterator object.
Okay, yeah. Is
So that was
iterator is so okay, is in I know what an iterator in Python is, but I don't know if that's the same thing that they're talking about in the question.
yeah. I think you are in a better position than I was.
Yeah, is it
So
like so is it like oh like you know like when you loop in Python for I in range 5, range is an iterator, right? Is this what
yeah,
they're talking about?
yeah. So yeah, range is a one type of iterator, but what they are looking for is something like after my research afterward, right? So
Yeah.
let's say we have a list looks like this, and list, and we can have a so let's say a list. We can say a list, and then we have a iter, and then we
Hmm.
can call uh, a list dot iter. So basically, this is an iterator object,
Okay.
and then what we can do is to call the next function on this iterator object. So each time when we call this function, and then it will render one element at a time, right? So
Yeah.
for the first time we call this function is one,
And
second
then
time it
2.
was two, and three, and then we out
Yeah.
of bound.
I actually think that's what
And
range does in Python. But when you do this for, I think it's built in that it's calling like range dot next each time. I think that's what's
yeah, I
happening
think
in Python.
this is this is what's going on under the hood,
Yeah.
and this is exactly what they're asking me under the hood. And actually, they went one level deeper, where they asked me to code this up in the object.
Oh, like
Does it
in
make
the
sense?
list object?
No, not in the list object, in the iterator object. So, for example, you have a class, right? So
Yeah.
let's say my iterator, and then you have a init function,
Yeah.
and then you have a next function, which takes in self, which also takes in self, and also you have the constructor function, which is the um, I'm gonna pass it. I mean, this is exactly what he did. I mean, he was like, I just have to pass it over here, and then you can
Yeah.
fill in the spot, right? And then another one will be the iter function. I I was so stressed out because I was already late in the interview when I was asked for interview. So we couldn't connect to the right room. After we connect to the right room later on, it was only 15 minutes late.
Was this in
And then
IDE or Google Docs?
it's a Google Doc.
Okay.
I
Um,
think you had the same thing, right?
yeah. I think wait, I don't know if this is like cheating, but Python has built in you can like let's say you initialize something and you have your passed in values, you could be like self like let's say it's a list or whatever, self dot list or whatever equal to the list that's passed in, let's say, right? Let's say it's passed in, right? I think you can
Yeah.
I I think you can do this for let's say length of self. You
I know
can
what you're getting at.
you can
Yeah, this is yeah,
yield. I don't think that's what they want though, right?
this is something like what I did. I call the built-in sorting function. But this is better than nothing. better than nothing, right? So
Yeah.
at least
I guess they
you
wanted
know.
like the manual, like, oh, which index are you at? Like you store like some like concept of which index was passed last or something, right?
Yeah, exactly.
Yeah, or
Yeah,
like
exactly.
yeah,
And
like
then
if you're doing the
when you
manual.
yeah, when you call that function and then you shift the index one at a time.
Yeah.
Yeah, and then until you hit the boundary where you cannot move forward any further. So I was asked that. I bombed it. So I'm not sure if you will be get asked that question again. That guy was from California. He was in machine learning team.
Hmm.
Um, and then I hated myself so much because I wasn't prepared when I go
No, don't worry
interview
about
from
it, man.
Google.
You just need to practice. You can try again in 6 months or something, right? Like, does
Yeah,
Google
I
let
was
you?
told that. Yeah, I was told that like a year, but we couldn't.
Oh, okay, okay. I don't know what the time
So
frame. I'm just googling. Some places say 6 months. Some places say 1 year. So I don't know.
yeah, I got a really bad feedback from the interviewer.
Ah,
Uh, yeah, so I wasn't really confident because I was when I came across this. So anyway, another tip for you who is going to interview is being confident. Even if I would have if I was given a chance again, I would probably like even I don't know nothing. I was being confident.
yeah,
Try anything that I you can like
yeah.
try to
That's
do
why
it
I'm
early.
here, man. Like I only found out about this site today. So I did one interview at 11 and one at just now. So I'm like, because
Okay.
I have very low experience with this, so I'm definitely like stuttering a lot and not speaking clearly at times, and especially my last Google interview. I would- I have problems with being tired, right, all the time. Like I feel like I don't sleep well, so I took a caffeine pill right before my interview, and I never take caffeine. I never drink coffee or anything, and my heart started racing. Like my heart, like
Yeah,
boom,
yeah,
boom, boom,
yeah,
boom, boom, boom,
yeah.
boom, 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 because of caffeine, right? And my body's not used to caffeine. So I was super nervous I wouldn't proceed because in the interview, I started thinking so hard that I froze. And I'm like, sorry, I froze. I told the guy, sorry, I froze at the beginning of the interview. I lost like 5 to 10 minutes at the beginning.
Yeah, I think caffeine pill is really helpful because it does not need you. I used it for my exams because I does
Yeah,
not need me to go to the washroom so often.
yeah,
Uh, Also it get me like concentrated to the problem that I'm giving. So
yeah, yeah, yeah.
I think I think it works for me as well. Um,
Yeah, in my case, it ruined me though because I'm not used to it. So it got my heart
oh,
racing.
okay.
I was so nervous. It got my heart racing. Like my heart started
Yeah.
beating
Okay.
fast.
Yeah, I think you have to learn how to write a jargon though.
Yeah, or maybe I just take like half the dose. I took one whole pill, and I normally because for somebody who doesn't take caffeine, I think it hits way harder. Yeah,
Yeah, you get a very strong reaction.
yeah, yeah, yeah. Are you in school now?
No, I'm actually working from home. But I'm reporting to Scotiabank in Toronto.
Oh, okay, okay.
Yeah, I graduated back in 2014.
Okay.
My background is not computer science. I'm from math and stats.
Yeah, okay.
Um, and then now, but I'm a programmer for
Which school did
Scotiabank.
you go to by any chance? If you're cool with that.
The U of A, the U of A.
Oh, okay, okay.
Yeah,
Is it?
I'm in Alberta. I'm Edmonton actually.
Oh, okay, okay.
Yeah, have you been in Edmonton before?
No, I've not. I've just been in Toronto my whole life. Oh
Yeah,
no,
so that's really good. So
I was born in Bangladesh. I moved to Montreal when I was 1, and then I moved to Toronto when I was 4. That's it. I don't know anything else. I've never
yeah,
been to Edmonton. Yeah.
I was born in China. I came here when I was 18. Now
Ah,
I'm
okay.
30, so it's 12 years ago. Um,
Cool.
yeah. So okay, so you know what? I'm not sure if you want to like connect a LinkedIn. So if you want to get on Prom again, you can ping me.
Sure.
Uh, would you be interested?
Yeah, I'm interested in just to share because are you like desperately looking for a job or just like you just kind of just looking for what's out there kind of like.
Well, this is like Scotiabank is not as good. It's not the same as Google, right?
Yeah.
So
So you're just trying
uh,
to you just want somewhere better or like for yourself right now or just
yeah, I was. yeah, I was really looking like 2 months ago, and then I
Yeah.
just interviewed a lot of companies. Google is one of them, and Scotiabank is one of them.
Oh,
And the Scotiabank came back to me, but Google like didn't, as you heard. So also Amazon kind of, well, they rescheduled me for another one. I haven't accepted yet. So because I really not prepared.
okay.
So yeah, so that's my story. So I'm really not like urgently looking, but I'm still casually looking for like my dream companies.
That's a good position to be in, to be honest, if you're not urgently looking. Because when you're urgently looking like me, it's gonna be devastating when Google rejects it.
Yeah. So I mean, my
Yeah.
recommendation would be spread out your chance. Yeah,
Yes.
go apply
Sure.
to for more. Like Google is not the only one company in the world. I mean, it's a good one,
For
but
sure. For
not the.
sure.
Yeah, yeah.
For sure. That's good
Eh,
advice. The problem is like there's more than one battle for me. It's not about just getting the. It's about a mental battle with myself. I'm not the most motivated person, and sometimes it's insane. Like if somebody else, outside observer, watched what I did and watched how I behave and do things, they would think I'm very irrational. And like, why don't I do these obvious things that, oh, like I should be applying to several places and stuff. But yeah, it's just a mental battle with myself, really. Like I have to treat myself like a kid. I'm like, oh, did I apply to a job today? Good job, good job. I did one job application today. Good job, good job. Like that sort of thing.
well, I've been doing those self encouragement to myself as well. So those
Yeah,
the mental encouragement is really important
yeah,
to keep myself move
yeah,
forward one at a time, one step at a time.
yeah, man.
So yeah, I totally get where you are standing, what you are getting at. Yeah, I'm more or less the same type person. Yeah.
Yeah, I think I'm a very extreme in that regard. Like honestly, if I told you my entire history with education and everything, like you'd be like, are you stupid? Are you like that's what you
Yeah.
you're gonna be confused at least. Like yeah, it's just something. It's just my own issue. I have to deal with it. Don't worry about it. But yeah, it's. I wish I was a much more motivated person personally.
Okay. Well, at least yeah, and then you find the need for to improve on in that area.
Yeah. I find just going on to lead code and practicing is kind of easy because I don't have to put that much effort. I do a problem and I'm done for the day. I'm like I practice for the day. So then now my mind is at ease. But really I should be practicing more and applying more, but you know, I'm doing the bare
Yeah.
minimum,
I
but yeah.
I think prom sometimes is more forcing than Lico. Lico
Yeah.
for me is like I'm pretty relaxing when I do Lico, which is not a bad
Yeah.
thing. But prom like pretty that really push me to the push out from the comfort zone. So I have to force myself to like finish it within like 30 minutes. So
Yeah.
prom sometimes does a better job. But the problem is for prom is the database. The problem database is not as big as Lico, and also
Hmm.
you don't see like
So do you see
what kind of
repeats
question.
often?
What was
Do you
that?
see repeated questions often?
Uh, I don't. I haven't come across any repeated questions because they keep track of
Oh,
the
okay.
question that I came across historically. But the problem is prom they don't ask like a mainstream problems, right? Not like those like a typical popular question like the top K element. I haven't
Hmm.
seen that on prompt, and also I haven't seen a ton of object design problems,
Yeah.
which sometimes will be one of the keys for object designs. Um, so it's like give or take, right? The database is not that great, but you get more like a
Yeah.
so some interviewer they maybe constructive feedback. So give or take. So I have to for myself I have to balance off between the two. So lead code is really like a really coding technically coding,
Hmm.
but prom is more like real interview like settings. Um,
Yeah.
so I
It's
have
been
to
helpful
like
for me for
balance the
sure.
two.
Yeah, so you might have Googled it already, but this is that problem, kth largest element in an array on leak code.
Yeah, I think I have done this before. I use a heap map.
Oh, okay, so
Not
yeah,
the mean. Yeah, he mean the mean heap.
yeah, Do you
But
subscribe
did
to
you?
the premium or do you?
Oh yes, I did. Yeah, I think it's not cheap. It's expensive, but I think it's worth it. It's
Yeah,
most of
it's
the time
for
worth
sure.
it.
It's yeah, for sure it's worth it. Yeah, the solution for this one has the thing I mentioned, the quick sort, or like I
Yeah,
think they call it quick select.
I'm gonna look it up and I have to learn the sorting algorithm again. I learned it before, but I could didn't
Yeah, it's
stick
it's
around
like
in my
one thing
brain.
you do it once in school and you never use it again, type of thing. Yeah, yeah.
Exactly.
But it is helpful because it was helpful here, right? So if you know how to do it,
Yeah,
you know how to alter it, you know how to modify it to solve this one faster.
yeah. I'm gonna do that right after this call.
Yeah.
Okay. Well, it has been great working with you today, and best of luck for your next Google interview. I
Thank
know
you.
your time is very important right now. You have only 2 days left.
Yeah.
Yeah, my last and recommendation is to look at the iterator.
Yeah.
Yeah, this is what I got asked. So I hopefully you come across it, you don't get bombed. You
Yeah.
get passed
Thank
for
you.
that question, and
Yeah.
yeah, and once again, best of luck. If you want to get connected in prom again, let me know. Ping me on LinkedIn, and yeah,
Okay, cool. All right, yeah, it was good. It
okay.
was good chatting. Have a good one.
Best of luck with
Yeah.
everything. See you next time.
Yeah.